Welcome to these Acma problem videos. In this case, this problem, we'll be looking at an order of magnitude example. Rather than doing a classic example problem where I will work through numeric results, I have a series of slides on here that I will be kind of stepping you through the thinking process of how to do an order of magnitude calculation. The question we're going to be looking at is whether or not every student in FGCU could fit in Alico or Reno, say, in case of an emergency. Now, the key part of setting up an order of magnitude calculation is figuring out what simple type of calculation you're going to do and what sort of approximations are you going to do. So, this is Alico Arena, and we need to know how large it is. Now, as you can see, it is not, it has a relatively complex shape with different parts of it. Parts of it include walls, parts of it are bleachers, seating might have multiple layers. This is a relatively complicated surface that you could stand on the inside. But our simplification is just, it's a rectangle. It's not going to be right. It's not going to give you the right amount of floor space to just be standing in, but it will give you something that is reasonable. It will give you something that is within a factor of a couple of the right amount of area that you can stand on, because you're just missing sort of some parts inside of here, but probably not 50% of this area. So I just went on Google Maps, used the legend, measured it out, and it's 100 meters one direction and it's 90 meters another direction. That gives you 9,000 square meters. So that's the amount of floor space you can stand on. Then the question becomes, how many people could stand in that area? Well, it depends on the person, quite obviously. How wide are your shoulders? How big is your stomach? How much personal space do you need? But we're going to do sort of a very simple approximation, which is that if you look from above, people form a rectangle. Google sort of human dimensions to see about how wide people are and how thick people are sort of vertically, and approximated that if you just multiply those together, the dimensions listed, you get a roughly 0.1 square meters. And then the simple calculation, so those are the kind of approximations of the problem. The simple approximation is that all you need to know is how, if every person takes up, some amount of space, and there's some amount of space to stand on. It's just it's the area over the total they can stand on divided by the footprint, the surface area that somebody's going to stand on. That'll be how many people can sit in there. It's kind of ignoring things like maybe some personal space, maybe the actual problems with crowds and how they interact and all those sorts of things. But just roughly speaking, you can do a nice simple calculation like that, and then you come up with a roughly 100,000 people could fit in that way. The student body is around 15,000 students at this point. So yeah, you probably could fit everybody inside of there. Again, maybe we're off by a factor of 2-ish. Maybe it's 70, maybe it's 50, maybe it's actually more than that because there's different layers that you can stand on. Maybe it's actually more like 120,000 people you could sit in there. But it's probably doable because you're about 10 times, this estimate still gives you about 10 times too much. It'd be more comfortable if we got an answer that was 1,000 times or 100 times larger or smaller, so that you could be absolutely sure. You may want to go back and do this a little bit more detailed, but yeah, it is sort of in a quick approximation. This is probably physically possible to kind of stuff everybody into Alico Arena if needed.